All right, my people, welcome back to this channel where we help you to have good understanding of mathematical concepts. All right, the last time I was there, we talked about uh, sector and the cones relationship. Okay, and I promise I will come with an example for us to have a good understanding. So let's look at this question. If we have this question like this, I hope you can see it. The sector of a circle of radius 12 centimeter. Okay, so the radius of the circle, if you remember from our formula the last time, the radius of the sector will be big R, is given as 12 centimeter, with a center angle, that's angle theta, equals 120 degrees. It's folded to form a right circular cone, and we are to calculate one, the arc length of the sector. Of course, you know that length of arc, the formula for length of arc is given as theta over 360 multiplied by 2 pi r. We are using big R here just for differentiation's sake. That's between the radius of the sector and the base radius of the cone. Okay, so this one will give us theta is 120 over 360 times 2. Pi is given as 3.142 times 12. Okay, here 1, 3, here 1, here 4. Okay, so we have 8 multiplied by 3.142. Okay, please you can use your calculator to get final value for that. All right, now let's go to the second question. It says the radius of the base of the cone. Radius of the base of the cone. So here, what you need to do is to remember the relationship between sector and cone. Remember, we said when a sector is used to form a cone, this relationship exists. One, the length of arc, okay, will be equal to the circumference of the base of the cone. Okay, and I remember vividly I said this circumference simply means like the perimeter. So length of arc here will now be theta over 360. Just want to go back to deriving, the formula just like we did last time. And the circumference of the base of the cone is given by 2 pi r. In this case, now that small r, it's the radius of the cone. Okay, if you cancel 2 pi on the two sides, we are going to have theta over 360 multiplied by r equals small r. Okay, we want to divide both sides by big R, so we have theta over 360 equals small r over big R. So this is actually the relationship, but for this question what we are asked to calculate is this small r, and it's already the subject of the formula. Okay, meaning the small r so the small r will then be the small r, sorry, I need to move this up a bit. Okay, so the small r now equals theta over 360. Theta is 120 over 360 multiplied by 12, and that's our small r. That's this this, that's 1/3. Okay, this, that's 4. So meaning the radius equals 4 centimeter. Can you see that now? Right? So the last question, question 3 says the slant height of the cone. All right. I put to you here that this one does not need any calculation. I mean this last one. If you remember the second relationship between a sector and the cone says the radius of the sector will become the slant height of the cone. So you can check it out by yourself. Cut a sector using a paper and fold it to the cone. Okay, you fold it to become a cone. You will discover that the radius of that circle from which you cut your sector will become the slant height, okay, of the cone. And already the radius of the cone has been given, so meaning the slant height equals 12 centimeters. All right, thank you for watching. I'll come your way again for more solution to questions like this. If you have any question, you can reach out in the comments. If there is any particular topic you want to treat, kindly let me know through the comments. Send in your question, any challenge, let's solve it together. Thank you. Bye.